All right, welcome back. Now we're going to talk about verifying trigonometric identities. Okay, so in the preceding videos, in the last section, we used identities to rewrite trigonometric expressions in equivalent forms. So now in this next section, in this section here, we're going to study techniques for verifying trigonometric identities. Okay, so we're going to verify that these identities are true. Now, in the next section, we're going to start talking about solving trigonometric equations. Okay, so there's a difference there. So let me add a couple of things here. Now, the key to both verifying identities and solving equations is your ability to use the fundamental identities and the techniques in algebra that you've learned. Okay. And using the rules of algebra to rewrite trigonometric expressions, which we've done several examples of. Now, also remember that a conditional equation is only true for certain values of the variable. Okay, for example, the equation sine x equal to 0 is only true when x is equal to some multiple of 2 pi, some integer multiple of 2 pi, right? Or pi, I should say. Okay, so so that means it's conditional on those values. So any multiple of pi is going to give you a true statement for sine x equal to 0. Okay. Now, an identity is an equation that is true for all values or all real values in the domain. Okay. For example, if I say sine squared x is equal to 1 minus cosine squared x, that is true for all values in the domain of x. Okay. The domain of sine x. Okay. What else do I want to say? Okay, so now, although there are similarities, verifying that a trigonometric equation is an identity is quite different from solving an equation. There is no well-defined set of rules for verifying trigonometric identities. So what I've done is I've written down the guidelines that you should use to help you verify that an identity exists. So 1, work with one side of the equation at a time. It is often better to work with the side that is more complicated. Okay, work with that side first. 2, look for opportunities to factor an expression, add fractions, or create a denominator with a single term. 3, look for opportunities to use fundamental identities. Okay? Now, if 1, 2, and 3 don't work, right, they don't help, then try converting all the terms into sines and cosines. That's number 4. And then 5 is always try something. Always try something. Okay? Now, for number 3, I also want to say that note which functions are in the final expression that you want. Okay? Sines and cosines, remember, always pair up well. As also secant and tangent and cosecant and cotangent. So remember, in all of the examples, there was some way where we took tangent and secant and we were able to use something like the Pythagorean identities, right? Or we saw cosine squared and sine squared, right? So look for those kind of things as well. Things that kind of stick out. And the more you practice, the better you're going to become. You're going to start noticing things a lot easier the more you work with them. You're going to see opportunities, right? You're going to notice things, okay, that you wouldn't have noticed before. But again, it comes with practice. So make sure you do a lot of these, and just don't do the examples. Go through the examples that I do. Look at other examples in the textbook. Okay. All right. Have a great day.